In this video, we will begin our review of exponents. Integer exponents. Repeated multiplication can be written in exponential form. For example, we see here a times a times a times a times a. This is a to the 5th power because we have 5 a's. Negative 4 times negative 4 times negative 4 is negative 4 to the 3rd power, as we have 3 negative 4's. 2x times 2x times 2x times 2x is 2x to the 4th. So in general, if a is a real number and n is a positive integer, then a to the n can be expanded as a times a for however many n factors there are, where n is the exponent and a is the base. The expression a to the n is read a to the nth power. Let's take a look at some of the properties of exponents. So let a and b be real numbers, variables, or algebraic expressions, and let m and n be integers. Here we will assume that all denominators and bases are non-zero. In property 1, we see the multiplication property. So this is that when we multiply like bases, that we can add their exponents. For example, 3 squared times 3 to the 4th power is 3 to the 2 plus 4, or 3 to the 6th power. Similarly, when we divide like bases, we will subtract the exponents. So x to the 7th power divided by x to the 4th power will be x to the 7 minus 4th power, which is x to the 3rd power. When we have negative exponents, so a to the negative n, we can rewrite this with a positive exponent by relocating that to the denominator. So having 1 over a to the positive n, which is the same as writing 1 over a and having that whole fraction to the nth power. For any non-zero base a that is raised to the 0 power, that is always going to be equal to 1. For number 5, we have ab to the m power, and that is going to be the same as having a to the m power times b to the m power. 6, a to the m to the nth power, we're going to multiply those exponents. We can also distribute our exponent to both the numerator and the denominator of a fraction. And number 8, the absolute value of a squared is equal to the absolute value of a squared, which is equal to a squared. So example 1, using properties of exponents. Here we can use properties of exponents to simplify each expression. Let's start off with example A. So I'm going to rewrite the values in example A so that our numbers and our variables are together. So first we'll have negative 3 times 4. A times A and b to the fourth times b to the negative third. Negative 3 times a positive 4 is negative 12. A times a, here we have two factors of a, so this is a squared. And b to the 4 plus a negative 3, which is just going to be b to the first power. In example B, we have 2xy squared, and we're raising that to the third power. That means that we need to take to the third power the 2, so 2 to the third power, x to the third power, and y squared also needs to be raised to the third power. 2 to the third power, that is 2 times 2 times 2, which is 8. X to the third power, and when we take a power to another power, we multiply those, so this would be y to the sixth power. Looking at example C, we see 3a times negative 4a squared, but that's being raised to the 0 power. And we know that anything raised to the 0 power is 1. So this will be 3a times 1, which is simply 3a. Finally, we have example D, where we have 5x cubed over y, and that whole quantity is being squared. This is the same as saying 5x cubed squared over y squared. Notice in our numerator, we need to take that exponent of 2 to the 5 and to the x cubed. So we'll have 5 squared times x cubed squared over y squared, which finally simplifies to 25x to the sixth power over y squared. So when we simplify our expressions, we want to rewrite those using only positive exponents. So it is not customary to write our final answer with a negative exponent. So we'll use our rules that we know, and we will simplify those. So let's look at A. A gives us x to the negative first power. Using our exponent rules, we know that anytime we have a negative exponent, we simply move it from the numerator to the denominator or vice versa, depending on where it is. So here, our numerator, x, is to the negative first power. So what we can do here is simply move it so that we end up with 1 over x. With b, we have 1 over 3x to the negative 2. It's important here to note that the exponent negative 2 is only acting on the x. It is not acting on the 3. In this case, in order to have a positive exponent, we need to move that x term with its exponent and make it positive to the numerator, so x squared. But we're going to keep that 3 in the denominator. So we end up with x squared over 3. Let's take a look at example C. There's a lot going on here. So we have 12a cubed b to the negative 4th over 4a to the negative 2b. The first thing we can do here is divide our numbers. So 12 over 4 simplifies to 3 over 1. I'm going to keep that a cubed in the numerator, but the a from the denominator is not where it needs to be, so we'll bring it up to the numerator and make it positive. Notice the b from the denominator is fine, but that b to the negative 4 in the numerator comes down to the denominator and becomes positive. Just an aside here, the way I usually explain this to some of my younger students is that when the exponent is negative, it's not happy where it is. So in order to make it positive, we move it. So if it's not happy in the numerator, we move it to the denominator and make it happy. If it's not happy in the denominator, we move it to the numerator and make it happy. So let's go ahead and then finish simplifying here. So we end up with 3a to the 3 plus 2, which is 5, over b to the 4 plus 1, which is also 5. Let's take a look here at how the entire expression is being raised to a negative exponent. When this occurs, we can simply take the reciprocal of the exponent and make that, or the reciprocal of the fraction, and make the exponent positive. So with d, the first step we can take is to make this y over 3x squared to the positive 2. Now we can take that 2 and make it act upon each of the terms inside. So that will be y squared over 3 squared times x squared squared. This finally simplifies to y squared over 9x to the 4th power.